The conversation on UFOs, UAPs, and non-human intelligence has long been shaped by experience, speculation, and secrecy. What's missing is a coherent approach, one that separates data from interpretation and evidence from belief. Humanity now stands at a threshold. Encountering a non-human reality is not only a scientific mystery, it's a civilizational challenge. We must move beyond ideology and secrecy toward a science of contact, grounded in evidence, methods, and shared human values. The Human Institute is building that foundation. The Investigating Non-Human Intelligence series is the first public multidisciplinary forum dedicated to developing the scientific and ethical foundations for researching our human encounter with non-human intelligence. The series convenes leading scientists, philosophers, and field investigators to explore new approaches, methods, and emerging data and findings to ultimately generate breakthrough discoveries in non-human intelligent phenomena. These one-hour presentations bring forward serious work by serious people, charting a roadmap for a new science capable of understanding and managing the unknown responsibly before it manages us. We invite scholars, experiencers, and all who seek clarity to join us. It's time to rise above speculation and take a deliberate step toward a grounded, evidence-based response to the existence of non-human intelligence.
Good evening, everyone. Welcome to this presentation in the Investigating Non-Human Intelligence series, an initiative of the Human Institute in partnership with UAP Med. My name is Reed Summers, and on behalf of the Human Institute, I'd like to thank you for joining us in this third lecture in the series as we continue this rigorous investigation of one of the most consequential questions of our time. Are we observing technologies of non-human origin, and with it a possible form of non-human intelligence? In this series, we're setting out on a new journey, one that brings together leading minds in science, research, and investigation to lay the methodical groundwork for what may become a new research and line of inquiry into the fundamental nature and reality of non-human intelligence. Within this new forum will be presented the key methodologies, frameworks, and investigatory practices necessary to build a credible, evidential basis for assessing the potential existence, presence, and activities of what may be a non-human intelligence. The series will chart a roadmap exploring 8 layers of this emerging field, from scientific and research foundations, put this on screen, signs of intelligence, consciousness and cognitive frontiers, communication and contact, psychological and social impacts, exposure and direct encounters, public safety and responsible engagement, and ethics, law, and international preparedness. We are within the first layer of this 8-part roadmap now, looking at the scientific and research foundations of this new field of non-human intelligence. Over the last 2 sessions, we have been deliberately laying that foundation. In the opening lecture, Dr. Michael Safone challenged us to rethink how science itself must evolve to study intelligence that may not fit our human categories or the known modes of intelligent interaction. Dr. Safone traced the historical limits of classical ufology and made a compelling case for moving beyond a purely forensic approach. He proposed a transition toward what he described as a relational science, one capable of studying intelligence not merely as an object, a signal, or an artifact, but as a pattern of behavior, of interaction, and agency unfolding within an event space. His lecture reframed the challenge of NHI as an epistemological one, how science itself must evolve if it is to recognize intelligence that may not communicate, signal, or even appear to us in ways that we already know how to detect. In our second lecture, Dr. Gary Nolan brought that philosophical framework into direct contact with practice, outlining how anomalous materials, biological effects, and sensor data can be approached with professional standards of evidence instrumentation, and analysis. Dr. Nolan discussed the concrete research roadmaps, standards of evidence, and methodical guardrails for studying anomalous materials, biological effects, and this sensor data. Importantly, he addressed how unconventional data, whether anomalous, firsthand personal testimony, or other noted effects of UAP, might be treated not as conclusions, but as pre-data, as inputs that demand better investigatory practices, research protocols, and cross-disciplinary validation rather than speculation. So together, these two first talks really established a critical foundation of science and research, a framework for how to think about the potential existence and presence of NHI, and a roadmap to investigate it responsibly. Now, tonight, we take the next step from how we should think about NHI and how we might study it to a sharper question. Are there detectable, non-natural optical phenomena in the sky detected before the satellite era? Are we observing potential signatures of a non-human technology operating in Earth's upper atmosphere and near space environment? And more broadly, what would the technosignatures of an actual non-human intelligence look like in our astronomical data? You know, for decades, science has searched the universe for deliberate signals, messages sent to be received. But another possibility is increasingly difficult to ignore, that intelligence may already be leaving detectable traces, not as messages, but as patterns, transient anomalies embedded in observational records that we already possess. The challenge here is not only in recognition, but in imagination. And today's speaker, Beatrice Villarroel, has employed both to explore how astronomy, historical sky surveys, and modern data analysis can be used to identify phenomena that resist prosaic explanation. I want to encourage you to ask your questions to today's speaker at the QR code that we'll put up on screen here or at the link provided. Please head over, ask your questions throughout the talk, upvote the questions of others, and we will have a lively conversation with Beatrice at the conclusion of her talk. At this point, I'd like to bring onto stage Ted Rowe. Ted Rowe is going to help me introduce Beatrice. He is the executive director and founder of UAP Med. Together, our two organizations have set out to create a truly multidisciplinary forum to build the intellectual, ethical, and scientific architecture for investigating the fundamental existence and presence of what may ultimately be confirmed as a non-human intelligence. So welcome, Ted.
Thank you, Reed. Thank you very much. Today's speaker, Dr. Beatrice Villarroel, is an astronomer whose research focuses on identifying rare, non-recurring, and anomalous phenomena in Earth's near-space environment through large-scale astronomical data analysis. She is a research fellow at the Nordic Institute for Theoretical Physics and has held positions at institutes including Uppsala University and Stockholm University. Dr. Villarroel is best known for leading systematic investigations into so-called vanishing objects, sources visible in historical astronomical survey data that have no corresponding counterpart in modern observations. Her work applies rigorous statistical methods to archival sky surveys, emphasizing long baseline, cross-epoch comparison as a powerful tool for detecting phenomena that evade conventional observational strategies. In the context of unidentified aerial phenomena and potential non-human intelligence, Dr. Villarroel's research is notable for reframing the problem as one of data archaeology rather than speculation. By integrating historical archives, modern instrumentation, and open scientific collaboration, her work demonstrates how rare, transient, or non-anthropogenic signatures might be identified without presupposing their origin or intent. Her research has been published in peer-reviewed journals and has attracted international attention for its methodical rigor and its implications for how science can responsibly investigate anomalous observations. So with that, I'd like to introduce Dr. Villarroel.
Hello. I'm very honored to be here. Thank you very much for inviting me.
Here.
So I'm going to be talking about searches for near-Earth artifacts, and I'm going to have assistance with the slides. Thank you for this help. And next slide. So what is it all about? Well, for me and like for many of us, this all boils down to one big question: are we alone? And many of us maybe already have an answer, or think we have an answer to this question, and many feel that we still don't. So there's probably going to be all kind of answers to that questions in the audience. This has, however, been a very important driving force for me in my research, in particular in the last years. And I think it is probably the greatest question humanity can tackle. Next slide, please. So what are actually the statistics? How does it look? Well, we do know that there are like 200 to 300 billions of stars just in our own galaxy, the Milky Way. You see the Milky, or a picture of how the Milky Way is, how it should look. It's a spiral galaxy. And we can imagine that if we just look at our own galaxy, we have maybe 9 to 40 billion of Earth-like planets that are inside a habitable zone from their star, where you can form liquid water. Also, we don't only have large numbers of planets. We have already found the building blocks of life, let's say like amino acid and nucleotides on meteorites and asteroids. So these are really great like starting points in order to have life in other planets than just the Earth. Next slide, please. So last year, there were a lot of news about a 3 sigma detection of DMS and DMDS in a high-ocean world, in an ocean world, where one has found these biosignatures on an exoplanet. After this detection came a number of papers falsifying it, but I'm not sure that those will be correct. We will see how this develops, because I think as they will get more and more JWST data, also the results and the statistical significance of the signal might improve. So let's see where this leads. Next slide, please. Last year, we also heard about signs of ancient microbial life on Mars through certain spots and through certain geological findings that one made there. Next slide, please. So here, when we talk about the DMS or about life on Mars, we're thinking about primitive life, because maybe the whole universe is full of planets that have lots of microbes, viruses. Well, viruses are not entirely life, but anyway, that might have simply lots of primitive life there. But how about intelligent life, which is life as intelligent as us or more intelligent, if we now count ourselves like intelligent life, which I am not sure. That's the real question. Are there intelligent civilizations out there, and have they already maybe been here? Which is an even more important question, and maybe they are already here. Next slide, please. So this is a question people have been working with since the 1960s. So since then, astronomers have been using radio telescopes in order to listen on other stars, trying to see if there is some intelligent, some typical signals that are associated with intelligence. And one has found nothing. After 60 years of looking for star after star and using these radio telescopes, there are 0 candidates. And then we have still maybe sampled something like 300,000 stars. And you have not only the SETI Institute, you have the Breakthrough Listen program, you have this FAST telescope in China that is also very active, and telescopes in Russia, and so far nothing. Next slide, please. One has also started searching for life, or like searching for laser signals associated. And for example, Space Laser Awareness has done some limited searches, but this is still a very small survey. And so far, no signs of laser communication from other stars have been found. Oh, sorry, next slide, please. So now when we think about a radio or laser, then we're assuming that some other civilization is going to be communicating and maybe streaming stuff to us, communicating directly to us some stuff. But instead of sending some beam of information from big interstellar distances, a civilization could also send probes. And it doesn't have to be huge probes, it could be small probes. They could send hundreds of thousands just to our own solar system. They could send hundreds of thousands just around the Earth. They could send billions and billions of probes, depending on how advanced they are, out over the whole galaxy. These probes could have AI. These probes could interact among themselves and exchange information. And these probes could be self-replicating. And who knows, like, to make things even worse, what if these probes already even know how to conduct human brain interaction so that they can get information in that way as well? So such probes could be doing silent surveillance of our planet. They could be residing on the surface of the planet or another planet. They could be on Mars, they could be on the moon, they could be on asteroids, they could be orbiting the Earth, and maybe they can even enter the atmosphere. We don't know what are the technological limitations of another much more advanced civilization. And with these probes, nobody demands that they travel faster than the speed of light. They could be traveling here for some 100,000s of years in a big mass and then just be here. Anything is possible, but the point is, we are capable of building things like the Voyager and Pioneer probes that can leave our own solar system. Why wouldn't another more advanced civilization be able to send something to us? Next slide, please. So, and that's has been the basic question for my research in the last years. I'm interested to search for potential extraterrestrial or non-human probes inside our own solar system, and especially close to the Earth. So what are different ways one can do? Well, we have actually a paper out there in monthly notices where we describe different ways briefly. One of the ways that I'm very fond of is that you can use pre-Sputnik images taken before the first human satellite was launched, before 1957, because then you know that there is no satellites in space, there is no space debris from us humans, and you can look for things that look like satellites, or that look like space debris, or have very typical signatures of being artificial in these old pre-Sputnik images. Another thing you can do is to use the Earth's shadow. So as the Earth casts a shadow, you can be looking inside the Earth's shadow to see if you see something that is emitting its own light. Then you will maybe find not every probe, not every technological remain, but you will be able to see something that is very active and actively emitting its own light. You can also use the Earth's shadow to separate between reflections and emissions and other things. A third approach is to use spaceborne telescopes, and then you kind of ignore all the stuff close to the Earth. And a fourth approach is by looking at debris and trying to see if the color can be used somehow to look for things that are a bit older. Now, these are methods to do it from the Earth. Now, if you want to send out a mission, you probably can also collect a lot of stuff from the Earth orbit, but here I'm just discussing some cheap methods, even like archival methods that one can use. Next slide, please. And so much of my work and of the work of the Vasco project, of the team we are working with, which is a good team of some 40 people are involved in various parts. Much of this is related to searching for reflections from such non-human objects. I'm talking about solar reflections. So, for example, if you have a very flat and a very reflective object, something that is, now this is not very flat, but I mean, you get the point. You have something that is very shiny, flat, and flat like a mirror, not like this candy stuff. And that is orbiting the Earth and rotating. Sometimes it might give off a very brief flash. And these flashes are very often called transients because it's something that appears and vanishes. Now, today, if you look at the sky, you have thousands and thousands of transients every hour, just visible to the naked eye, and even more that are not visible to the naked eye. And to compare with, if you would have an asteroid or something that is just a round thing, they don't leave these flashes. What they are leaving are streaks. Natural or objects or rough surfaces, round, all these things are leaving streaks. Meteors, streaks. And if you are looking into these images that I'm looking into, they have been taken during 50 minutes when the telescope is tracking the stars. And there is very easy to separate a flash from a streak. And these flashes that you can see on the sky today, they usually last something like half a second or up to a second or so. And yes, these images are usually taken during 15 minutes of exposure. Next, please. So what can you actually predict as typical signatures of ET probes? Well, you can not only have one flash, you might have multiple flashes, multiple transients. You can have triple transients. And very elegantly is if you find many of these along a line, let's say, because then you have an easier time to actually say that, yes, these are flashes and it looks like one object that is moving also. Next slide, please. So how have we been doing this? Well, it actually started with a completely different project idea. I was interested in looking for vanishing stars when we found something else, but what we essentially have been doing is that we've been looking for vanishing stars or objects that are there in old images from the early 1950s from Mount Palomar that had these big glass plates, and these big glass plates have been digitized and you can get access to the digitized data online. And we'll be comparing them with images of the sky as it looks today, like from 10 years ago, pan-stars, and try to see everything that differed. Next slide, please. So the Vasco project, well, we were interested in this vanishing star, finding one star that vanishes, and we actually went through something like 600 million of objects with automated methods. These methods were developed by the Spanish Virtual Observatory, and they're a government-funded research group, and they have used their tools in order to extract these transients, and thousands and thousands of short-lived transients were found, but we never found a star that vanished. So this kind of, we never found this sort of steady star that you can see multiple images that later vanish and never find it again. But we saw thousands and thousands of these brief flashes that you find all over these photographic plates. And that is, of course, a mystery. What are they? We started wondering. We have also done a citizen science project where we have been allowing citizens to compare images from the early 1950s with these pan-stars images, and they found lots of flashes. Next image, thanks. So for the citizen science project, and these are some of the people who have been leading it, and we have been working a lot with schools and with amateur astronomy associations, especially in Algeria and in Nigeria. And Hisham Gregory is working on summarizing the paper. Next slide, please. So this is one of the most interesting findings that were done, and it has been done by Professor Enrique Solano at the Spanish Virtual Observatory. He has been leading this big process of automating the process of searching for transients. And you see here a triple transient. It's a beautiful plate. It's a very clean plate. You can see it here on this image from 19th of July, 1952, and then it vanishes. And apologies for my cat in the background. Next slide, please. So do we actually see some signatures of probes in the data, like aligned transients? Because one of the things we should be also finding are, or might be finding, are alignments. It would be an even safer way of searching for these probes. Next slide. Here are some examples of actual alignments. And here you see 4 transients in a line, and there are 2 more, but you see it here. And the probability for such an alignment is 0.003. And this has been published recently in publications of the Astronomical Society of the Pacific. And this candidate is from the 5th of August 1954. Next slide, please. Here's a second example with a probability in 1 in 10,000, where you see 5 in a narrow band, not along a line, but in a narrow band, and it's from the 27th of July 1952, also in the same paper. So obviously there are things that are reminiscent of artificial objects in these old catalogs that shouldn't be there. And next slide. And here is where it becomes very interesting, because 2 of our absolutely strongest candidates that we found happened to be during the 2 weekends of the Washington 1952 flyover. And now the question is this just a coincidence? Because one thing if you have one image that coincides on those days, but when you have 2 of your best candidates are coinciding, then you start really wondering. Next slide, please. So for those who don't know what it is, it's one of the most famous UFO flyovers, and it happened during 2 consecutive weekends when lots of people, especially very credible witnesses like pilots and stewardesses and radar operators on multiple airports saw mysterious objects. And this was a huge thing. So it happened 19th to 20th of July and 26th and 27th of July. 2 of these weekends, we also had these strongest candidates. And the interesting thing here is that it was so many news over all United States that the US Air Force held a press conference where they were saying, no, the radar operators were wrong, and people have misidentified aerial phenomena that are natural, etc., etc. And this was done with the help of, and this kind of debunking was made with the help of Donald Menzel, who was a famous astronomer at that time, but also a famous UFO debunker. And there are good stories about him that I will not dive into here, but if you want, read Ryan Perky's essay that he posted 2 days ago. So Ryan Perky, he has written a really important essay about Dr. Menzel. Next slide, please. So therefore we have been wondering, is there a correlation between these transients that we see on these old photographic plates and UFO phenomena? And we do indeed have a paper now that was published in October in Scientific Reports. It has 111,000 accesses, and where we actually do find such correlations. Next slide, please. So Stephen Breuel has been leading this work, and he has used 107,000 Vasco transients just from the Northern Hemisphere that Enrique Solano and the Spanish Virtual Observatory have gathered with fully automated processes. And he has used nuclear tests from Soviet, UK, and Britain, and UFOs from what is it called? From the UFOCAT database. And sorry, I just got distracted. And so what happens here is that he has used this different catalogs, and he has now looked at various correlations. Next slide, please. So the first question is if there's a UFO-nuke connection, and this is a very important thing. I think many of you know about the very interesting testimonies that have been happening, by Dr. Salas, and where they saw missiles, where they saw UFOs coming in at a base that had nuclear missiles. Also, there is the famous UFO nuke book by Robert Hastings, and there are lots of documented research on this connection. And So it's a valid question to ask. And this is exactly what has been done here in this paper. Next slide, please. So Steve, he has done the statistical studies here, and he can see that within the day after a nuclear test, you see a 68% increase of transients. And also, if you now include UFO sightings, you have an even larger increase of transients. So you combine them, that you have both UFO sightings and nuclear tests, and you will double the number of transients as on a control day. This correlation, however, vanishes after the 17th of March 1956, when also around those dates they stopped reporting UFOs near the nuclear production sites, which is quite interesting. Of course, there are still more transients happening after 1956, but just the correlation vanishes after that. This suggests also that transients are real observations, because still to this date, there are people who are trying to suggest that transients are just plate defects. But of course, the plate defects are not going to correlate with UFO sightings and nukes. Next slide. So here's one way how we have been imagining it, and that is that the Vasco transients might be the astronomical optical counterparts to UFO events. So by searching for these kind of transients, we might be learning a lot about UFO events. Next slide, please. So can we actually prove that these flashes that we see, these flashes, these objects that appear and vanish within one plate exposure, can we prove somehow that they are caused by solar reflection, that they are no plate defects, that they are nothing else, but they really are associated with solar reflections? And the answer is yes. Next slide, please. And this is another paper published in PASP recently, also in October. And next slide, please. What we have done here is that we have tested this hypothesis. And to our use is the Earth shadow, because the Earth shadow is great. And we're not talking about nighttime, because of course all observatories only observe in the nighttime, but we're talking about the geometric shadow that becomes narrower and narrower at higher altitude, and it's just like 8.7 degrees in radius at 42,000 kilometers altitude. And at that distance, what you will see is this like small like round shadow. And you can try to count the number of transients inside the Earth shadow. Because if our flashes are really solar reflections, what should happen? Well, inside the Earth shadow, you should have fewer of them, or none at all, but at least fewer. There should be a deficit inside the Earth shadow if these transients are caused by solar reflections. However, if they're caused by plate defects don't know where is the Earth shadow, because of course they might be somewhere on a plate, but no region on the plates and nor any plate defects will follow the Earth-Sun geometry that is time dependent and varies. So it's a very simple test. Do we see a deficit of transients in the Earth shadow? Next slide, please. And what we see here is I show you here just the theoretical comparison to what you to the expectations with the theory, and you see a very, very big deficit, 22 sigma, with a number of expected transients in the Earth shadow. There's simply a huge deficit, and both at 42,000 kilometers and at 80,000 kilometers altitude. Now people say, well, hey, this is just theoretical. How about if you actually take into account the real sky coverage, because the telescope, maybe they pointed more in one direction at a certain time than another. Okay, so then you actually take into account the real sky coverage, where they were watching at what time, and you can even include, you can even say, okay, let's ignore the edges of the plate where you have more likely to have defects, because you do also have plate defects. So you can ignore the edges of the plate where you have more plate defects, and you follow the sky coverage. You know exactly the time where they were pointing. You construct a control sample based on this, and you still see a very, very big deficit in the Earth shadow. So no matter what you do, you're going to see that there is lacking transience in the Earth shadow. And there's a deficit of roughly 30-35%, which suggests that like 1/3 of all our transients are related to solar reflections. Next slide, please. So these are the implications. Roughly 1/3 are consistent with solar reflections. And this requires very flat, highly reflective surfaces in orbit. And I'm talking about things like glass, like mirrors, like polymers. It also implies that we have tens to hundreds of thousands of these objects in orbit around the Earth. So it's not one or two of them. It's a lot of them, because actually our photographic plates are full of these. And what it also implies, to just make it even like scarier, is that a lot of these dots that astronomers have seen for 100 years, they have seen them, and they have assumed that these are just plate defects. They have ignored them. They thought it was noise. And they said, unless you see an object on at least 2 different images, ignore that point. A lot of these things, there has been an important signal in the data that has been overlooked for maybe 100 years. And that makes it very, very interesting. Next slide, please. So this, of course, tells me that we need to search for NHI artifacts. We need to look in space. We need to look inside our atmosphere. We need to look in the oceans. We need to look on the ground, and we need to look underground. And we need to unite all these efforts in systematic ways. Because if we have hundreds of thousands of these artificial objects in orbit around the Earth, imagine how many we have here. There must be lots of them as well that have somehow been overlooked or ignored. Next slide, please. And here I want to make an example. So Dennis Åsberg is my colleague and who I work with. And we're actually now working on setting up something together related to these searches in these 5 domains. And so he did a very important and interesting discovery that is called the Baltic Sea anomaly, where he found, as a diver, a very mysterious object at 90 meters depth in the Baltic Sea. And every time he goes there, he has lots of troubles with GPS and electric failures of the equipment, like every single time he has been there, I think. And you can see here, there are artificial looking shapes on the side scan sonar image, but also on the images taken with the underwater robots that I can show you in the next, please. On the upper left side here, you can see this right angled in the yellow image, like right angles that they don't look very natural. On the lower image, you will also see the same right angles, and there is even something looking like a wall and a wall molding there. And some people will tell you it's a geological formation. Who knows what geology can create, but it does look really weird. Upper image, you can see on the left side, it looks like a frame with a circle inside. And if you look below, you see actually a zoom in of the same circle with a frame around it. And these are things we hope to get better imagery of on the next expedition. And Dennis is leading these expeditions now to finally try to understand what did he discover in 2011. Because maybe it's something related to non-human artifacts, maybe it's something related to something totally different, but it looks like a very interesting candidate. Next image, please. Yes, we had actually 2 new expeditions in 2025. There's a team, it's a collaboration between the Society of UAP Studies and Maxifone that you already have heard, the Stockholm University, the University of Würzburg, CQR, and the Sigma 2-3AF in France. And yeah, we do have some new data that is being analyzed. Next slide, please. So where next? Well, of course, like I mentioned, Dennis and I are going to try to find ways of exploring non-human artifacts in all domains, from space to the deepest oceans. But also I'm having this project Exoprobe. We will try to look for these objects in the modern sky, not only in this old photographic place, but in the modern sky. And so next slide, please. So what is the idea? Well, of course, ideally you want a global network of telescopes, but we are a little bit more humble. We're going to just try to set up a network of telescopes in United States, New Mexico, Arizona region, and with the goal of trying to look for not only objects that are non-human, but maybe active probes. And next slide. So searching for active probes is much easier than searching for, let's say, something that is reflecting the sunlight, but we will do that too. We will do both of them. So when you have active probes, like if you look here, you can use certain tricks like the Earth shadow. We will come back to it later. But in general, what we want to do is to detect something. We want to localize it, and we want to verify it, like by using multiple telescopes, and we want to be able to replicate the finding easily. And how does this differ from, let's say, Galileo project and those? Well, the Galileo project, they are looking for basically anomalous objects. They are looking for things that don't fit anything else. While we are looking for very specific and identifiable signatures, these flashes that I mentioned several times, these transients from an ET probe. We are also keeping with a search range from 35,000 kilometers altitude, because we don't want to look inside the Earth's atmosphere. It's much easier to just look outside and try to minimize the background of human objects. And we want to minimize the number of false positives. And we want to try to get some kind of both spatial resolution, time resolution, and spectral resolution if possible. Next slide, please. And to do that, we need, of course, the appropriate instrumentation. Currently, we do have one plane wave delta rho telescope that is used. Next slide, please. And the main telescope stands in New Mexico. We have a collaborating telescope from the Space Laser Awareness. Next slide, please. And like by extending and having multiple telescopes, the good thing is that we can then measure the parallax and the distance to the object. We simply will triangulate it. Next slide, please. And so now we have these two telescopes there. Well, one is for taking spectra, and the other one is for taking images. But we are going to need more telescope for the images. Next slide, please. And as I mentioned, we want to stay outside the atmosphere because it's easier to avoid all the airplanes and ducks. Next slide, please. And I've been mentioning this before, but the Earth shadow can help to filter out all solar reflections. Now, when we were imagining the exoprobe in the beginning, we were thinking, oh, it's going to be great. We're just going to look for all these active probes emitting things, and it's going to be super exciting. We can look for the UFOs. But we never thought about these VASCO results. We were not aware of how many of these interesting objects are there, and that will be filtered out with Earth shadow. So we are now trying to use like multiple approaches to the same question, both looking for active probes, but also try to complement the VASCO studies by looking at the number of objects that actually are reflecting sunlight and comparing them to the VASCO numbers and objects that we can find there. Next slide, please. And yes, and one of the things that we of course hope to do is to get real-time spectra of any emitting object, because then it's going to teach us more about active probes if we are lucky enough to find one. Next, please. Yes, and adding more telescopes is what we will be hopefully be doing over time, but slowly, because we want to be always working very systematically and carefully. And because by having many combinations, we will have much more accurate measurements on the parallax and be able to localize things much more accurately. Next slide, please. And this is an animation that is not making itself very well in PDF format. It was intended to show you how the exoprobe worked. we can do that another time. And jump to the next slide. And of course, if you know people who want to collaborate with us and to extend the network, we will be very happy to collaborate with both professional and advanced amateur astronomers that might have equipment that is compatible with ours, which is like CMOS cameras and good plane wave delta rho telescopes in New Mexico, in Arizona, and in California. Next slide, please. And yes, this is where we are going. And I think we really need to take this search for non-human artifacts very seriously. There are specific signatures we can look for, which are these flashes. We don't need to try to imagine something that is so anomalous that it doesn't fit in with everything else. Let's just look for these very real, very physical signatures of flying saucers, if you want to call it that way. And we really need to do this very systematically, search everything from the oceans to the near Earth orbits. And I think this is where the future of ufology has to go. We need to be specific, and we need to work with hypothesis-driven methods, because when we have our hypothesis clean and clear, it's going to be much simpler. And with that, I would like to thank you all and express gratitude for allowing me to speak here today. Thank you.
Thank you, Beatrice. Fascinating work, very compelling data and findings. I want to thank you for your original and highly creative approach to going back into the pre-Sputnik, pre-satellite era to see if these transients were present, and indeed you did find what you found. So a very novel approach, and I think it really was an eye-opener, not only for the UAP community, but increasingly at the edges of it into the scientific community. And I'd like to get into that with you. I'd like to invite onto the stage again, Ted Rowe of UAP Med. And I'd also like to invite for the first time to the stage, Chuck Schreiner. Chuck is the impassioned, bold, and enthusiastic coordinator of this initiative. And he's been working with all the speakers, getting out all of the outreach and helping make this a reality. So thank you in advance, Chuck, for all your work.
Thank you.
Working with the Human Institute on this. So now we're going to go into questions, and Chuck, I'll let you take it away.
Beatrice, first of all, that was just, I'm just so amazed by the work that you're doing, and and to do it on a shoestring budget, I just creative kind of thought. It just kudos to you. So we have lots of questions. I'm going to start with I think you probably saw this as we prepared, and I'll just start there. Beatrice, what position, stance do you think Norway, Sweden, and Finland take on the subject, on the subject of UAP as countries? Is there formal interest or rumors of secret operations on that matter?
I have no idea. I can only say that there's a lot of stigma here still. At the same time, I actually got, for this research, I got a government grant. So there's at the same time as there's stigma, there's also openness in the Swedish scientific community, obviously.
Okay.
And I think if we look at the situation here, there is the Swedish media is not very open for the topic. They are very close-minded about the topic. You only have one expert who always talks anywhere, and God forbid if you disagree with him. So it's a very kind of stigmatized environment in the media, and I think that needs to improve. And that's the same thing in Denmark, I heard, and I think it's the same thing in Finland. I don't know how is the situation in Norway. I know they have a very good leader, Renate in UFO Norway, and I think they're very lucky there. So
thank you.
Ted Rowe and I have packed the question list with a lot of questions. So for the audience, please again ask your questions now. It's not too late. We'll get them in the queue.
So taking the highest sigma transients and within a bounded time period, would it be possible to extrapolate a range of estimates regarding the quantitative presence, i.e. number of per week, and the qualitative presence, either sustained or intermittent presence, interest in specific region of the Earth, of these objects?
Yes, you can learn quite a lot if you actually explore. Now we have like 1/3 of these we think are related to solar reflections. The other 2/3 might be anything, including plate, if you see them as noise. I think the other 2/3 should be regarded as noise. But you can try to learn, let's say, the altitudes. That's something we are doing now in the last days. We're trying to look at the range of altitudes where you can see these transients. Where is the highest density? You can try to also estimate their sizes. We haven't done the modeling yet, but you can try to, from the luminosity of them, you can probably model if they are 10 centimeters or if they're 1 meter in size. And of course, it's easier when you know the rough altitudes. You can probably learn a lot of things by doing all this creative modeling. We haven't gotten that far yet because we are still trying to work with potential biases when we look at the data. But what we actually really want to do is to try to replicate the same thing with another telescope rather than just Palomar, because the question is, what if it's something about the local environment on Palomar that makes you see all these transients, but maybe another telescope that is in France is not going to see as many. So you want to know that. You really
if I can
want
do
to know
a
this.
quick follow-up question, because there seems to be this correlation between these transients and nuclear tests or detonations, as well as reported UAP sightings. Is there any more granularity possible in the existing historic data set where you can say, actually, there was a preponderance of transients over Oak Ridge National Laboratory or over the Pacific coastline, or objects of a certain size?
I'm sure you can learn more, but when there is much more to extract from the data, surely.
Okay.
We haven't done it yet.
Okay. I'm, as an amateur astronomer, I'm really envious of your plane wave telescopes, but that's a different conversation. Next question. What methods currently exist that could give real-time observation of capabilities of anomalies in the upper atmosphere and near space environment, given a crowded orbital environment and the problem with space debris? What methods like radio occultation could be a viable way to detect anomalies?
Well, I think the way how we've been thinking is really that you look for not any probes, but that those that are active and blinking, let's say, that are emitting, and by using the Earth shadow. Because doing that, you remove all the satellites, you remove most of the NHI artifacts too, unfortunately. But maybe you can find some special, I don't know, specially equipped alien spaceship or so if you are using the Earth shadows. I think that's the cleanest technique, in my opinion. But that you look inside it, you reverse the thing we did with the Vasco. With the Vasco, we filtered out. We were looking for the visit in the Earth shadow in the 50s. But if you're today and looking at the sky like with a modern thing, maybe you just try to get rid of everything that reflects sunlight, and you just look for something that is active. That's one of the ways. Or spaceborne telescopes, looking further out. Is also.
And I guess my question, which I think would be on the minds of a lot of listeners, is, so this was done in a very special time period that will never come again, will never not be in the satellite age. So now what? Is there a way to begin to detect these through other means, whether that's detecting, radical kinematics, instantaneous acceleration, or using other satellite-based kind of remote sensing or observing capabilities that we already have? I'm curious if you're aware of any other promising
I'm
avenues.
a simple person. I would go up there, cast a big fishing net, and just take down lots of objects. That's what I would suggest. Or go there and send up a lot of sensors and photograph all these like objects that might be there. But I think we need space missions. We need space missions and really somehow be able to, let's say, if you have an object that has been there for some thousands of years, it might have many more micrometeorite holes than it might have other features that are indicating that it has been there for a long time. So by bringing down the garbage, or the things that we think is garbage, or that things that they told us is human space garbage but might not be, I think that's the way forward. And by photographing all that, we sometimes can't use exactly the same methods, and we need to find new ways of approaching it, new ways to look for it. But maybe it's not always going for the, now I took an example of something that is extremely expensive, but sometimes it's the way how you frame a question, asking the right question. And maybe we just haven't asked the right question yet of how to detect them today, because people have been thinking too much about maybe the anomaly, like the UAP definition. I prefer to think of the flying saucers is going to make life much easier, I think.
And Beatrice, really quickly, when you say that, do you mean in the sense that those are acknowledged morphologies of a structured object or craft versus UAP as a catch-all, which could mean pretty much any phenomena?
I think the UAP as a, okay, so now I'm going to give you my conspiracy thought. So I think that the broader we like, the broader category we have, like UAP, is a dumping category. Is a thing that doesn't fit anything else. When you use a dumping category, you don't have a real hypothesis. And then you can always use, people, what they do is that they use the exclusion method, not the scientific method, when they investigate the UAPs. I think it's a trap. It's a trap that you make it broader and broader, and you never know what to look for. You just go on in a circle. But when you specify it and you say, I'm going to look for my flying saucers, ignore the stigma. You go for the flying saucer-like thing. You know precisely what you look for. You know precisely how to define your, like, what to look for in the data set, how to make your experiment much cheaper. It will take down all the cost for your experiment. And that way, you simplify the life. And I think also today, when we look for things, we shouldn't be saying that we look for UAPs. We should say, oh, yes, I know there are orbs, and I know there are triangles, I know there are a lot of other interesting phenomena, but by being extremely specific, like, for example, about the flying saucers, we're going to have an easier life trying to detect them even today. We just need to be very specific and hypothesis driven, and using the scientific method instead of the exclusion principle. And that's my thought about it.
I'd like to speak to that for a second. Back in 1999, Dr. Haynes and I came up with the UAP term as a pronoun with a definition. And we promoted that through our work at NARCAP, working on aircraft and aviation reports. It seemed like the simplest, most direct way that we could go with a limited budget to find information, to move forward. We couldn't use the term flying saucer. We couldn't say UFO. Pilots wouldn't talk to us.
What term was it?
UAP. That was the term that would let people speak to us. However, as you say, it's a dumping ground. It isn't specific. It doesn't really define what it is we're after. And as the
what did the A stand for, Ted? In that standpoint?
Aerial. It meant unidentified aerial phenomena versus anomalous phenomena when the government changed the terminology. So my point is that as the stigma inhibits our ability to speak directly to the problem. We've had to find workarounds and all of that. And I absolutely agree with you 100%. You speak to what you're talking about with a level eye. We have evidence. It is debatable. And there's no reason for us not to take a stand on that. Of course, we want to do it in the most reasonable, rational, scientifically supported fashion whenever possible. But I agree with you 100%. Call it what it is.
I think the problem really arises that there's some of the, I observed here in Europe, you have some of the serious UFO groups. They are afraid of talking about NHI, or they are afraid to talk about anything related to green little man. So then they try to tilt it all into UAP, and then it becomes like a totally different question, because if you make it sound like if it's something military and can be human and secret projects, then I don't work with it anymore. That's not my thing. My domain is looking for aliens, not looking for secret projects. And it's a little bit of a problem. Like, being clear, it's regarded as being ridiculous, but at the same time, it's also the most honest approach and most scientific approach. And it's sad that they created that stigma. Really blocks science.
It really does. And I think that the solution about it is leadership. We lead by speaking to what we know and understand. And along that line, I did have a question for you there. Working with accessible data sets that in an inexpensive way, can you think of any other data sets that might be interesting in that regard?
Well, the spaceborne telescopes have produced very interesting data like Kepler and TESS, and people can try to use those if they're interested in looking for non-human artifacts. It's going to be a little bit further out, so maybe you will miss the closest things. So that's a possibility. And there are data sets from Ukraine, from the Vatican Observatory. I don't know what they will say there if one uses their data sets. There are data sets from Sonneberg. Where there's a number of them. Not all of them have been digitized. So the problem is like, what has been digitized? What is available for us?
Sure.
Because digitization is a complete project by itself.
Right.
And it can take years. So yeah, there are other data sets as well. I think we really need to think about how to use available existing data, because the problem isn't the lack of data. People say always the problem is lack of data. The problem is the lack of questions and imagination in formulating the question and doing the work. I think the data is all there. It has been there all the time.
That's a powerful call to action, and that's definitely at the spirit of this series. And our collaboration here is really to broaden the lens, to ask those questions that are outside the bounds of the traditional kind of line of inquiry within science and in the public sphere, and use what we already have and use these emerging capabilities in terms of machine learning, where it can be garbage in and gold out, not garbage in and garbage out, right? So there could be a fundamental paradigm shift in how we engage with data. And so thank you for spearheading that. I also just want to call out that the SCU has done some important Scientific Coalition for UAP Studies, some important research and analysis of the taxonomy of reported craft shape. And flying saucers are a well-acknowledged craft morphology, historically, less so in the present, which is interesting in that, if that were the craft of a specific non-human, intelligence, and it disappears in the historical record, that might suggest a transient nature in terms of what is engaging when. It's not an ever-present phenomenon. It's changing and shifting, and we could gain some potential insight into that by observing the craft shapes and morphologies. And there's going to be a summit up ahead. Yeah, the UAP summit, which I'll talk about at the end of this event, is going to be highlighting some emerging insight into what those morphologies are. So save that for later.
So I'm going to skip a couple of our internal comments and questions to Beatrice and get down to some of the viewers. Have other observatories given you plates from the 50s for you to look at? Whoops, just vanished. For you to look at during the same dates would be perfect. So have you gotten other data from other observatories besides the ones you mentioned in your talk?
And we will be looking. We haven't, nobody has contacted us and said, okay, we have plates here, but we are aware of that Sonneberg has. So we will talk to them, and we will talk to those like Lick Observatory and various plate collections.
Thank you. Next question was, what are some of the biggest challenges you've been facing so far?
Let me see, a lot of misunderstandings going around about the work when someone reads a paper sloppily, and it's people copy the wrong thing and misunderstandings are spreading. So that has been a frustrating thing to deal with, and people who usually spread misunderstandings, especially if they are from the MetaBunk forum, they don't want to correct the things, even if you ask them, hey, could you imagine to correct something? No, you'll have lots of excuses, but they will not correct anything. So that's one of the things.
Yes, I've seen you wage a few of those battles on Twitter.
Yeah, I don't even engage anymore. It's like, well, everyone have the right to read. It's everyone's responsibility to engage in material and read what might be right, might be wrong. And yeah. So that's been one challenge.
Sure.
Second challenge is stigma still. Even among UAP scientists, people are become very cold and a little bit sharp other UFO researchers. That's not so fun to deal with, but that's just human nature, I guess. So, but that's
Tag
okay.
along
I had many
question.
beautiful things.
Yeah. Beatrice, in the traditional kind of or mainline astronomical community, how has the research been received or not well received? Any thoughts on why and how that could be, encouraged into a broader kind of astronomical community inquiry into
I
what
had
you've
some
discovered?
people who I never expected to be positive to actually write some very nice things, that they got interested in it. Like some people who I always thought were super skeptical about UFOs, that thought that, okay, this actually now there is a way to study the question of UFOs in a real way. Now there's a way how we can try to replicate or study. So that has been a very nice thing. And of course, there's a lot of people who just say, oh, it's plate defects. Plate defects. You have a complete choir of people who say it's plate defects, but nobody will explain me why the plate defect is avoiding the Earth's shadow and why the plate defects are running around to avoid the Earth's shadow. Because, of course, the Earth's shadow is time dependent. It's moving. It depends on the sun and the Earth and the geometry. And why they are avoiding them, nobody can explain that. It's easier to just scream plate defects. So
when you bring that up, how do they respond to that? Did they just change the subject, or?
There's another way how one then does it. I mean, ad hoc assumptions are the easiest way among scientists. Then one person, like he said, well, two type of feedback I got then. Oh, maybe it's some systematic effect. And you ask them, okay, explain me a mechanism for the systematic effect. Because just saying systematic effect, it doesn't tell you anything. It's just a term you throw out. You need to come with a plausible mechanism. No reply. Another person said, but wait, if you have so many, a big fraction of contamination in your sample, then the sample is invalid. And you ask them, okay, so if you make the sample invalid because there is noise, you have to close CERN, you have to close LHC, you have to close a lot of medical studies. We close 95% of every statistical study ever done because there will always be noise. And it's interesting, to what extent people try to go to just ignore a result.
Yeah, I think of this as not just a technical issue, but it's a cultural issue.
Yeah,
the core of it, that we're really resistant to change. Particularly, this is not just change. This is change. This is huge kind of event in human history that it's difficult to wrap. It's almost like a developmental need that a human being needs to accomplish in order to wrap their head around this and see it, with at least curiosity.
I think so too. I think people are afraid often, and the scientists are more scared than others because it's a bigger shock for them, I think.
I think
one tries to deny.
Think back to Michael Saffon's statement in his lecture, where there seems to be this kind of psychology of impossibility, where it cannot be, therefore it isn't.
Right.
Where actually, no, the observation, though an outlier, is an observation of an actuality, therefore it must be, and therefore we have to figure out how it can be and revise our notions about just about everything, if necessary, to account for what reality is presenting to us. So how to get over that hurdle? Is it how to get the 51st grain of rice on the scale so that the scale starts to tip internally? It's a challenging process.
Yeah, but I think until then, most scientists will try to say it has to be plate defects. They must be somehow following,
right,
knowing where to go
on
the plates.
Yeah.
Or so we will see.
Defining rationalism, a rational approach to something before you know what it is, is not wise. I mean, the point is to collect enough data to develop an ability to understand it. And if you're starting off with that isn't possible and everybody's crazy, then clearly you're not going to get anywhere with it. And that's why this series is so important. We're bringing rational people together to make rational presentations about rational data, and we're asking people to make rational understandings about it. And hopefully we'll achieve that goal. And thank you very much for coming here and adding your weight to the conversation. It's very important.
Thanks.
Yeah. So I want to also thank the 583 people who are watching live right now. So thank you so much for being a part of this new rigorous methodical inquiry into what has been in the fringes for too long and has to be brought into the center lane of human thought and analysis. So thank you for being here. Maybe we can put up the Slido QR code and link one more time in case some viewers would like to ask their questions of Beatrice. We'll put that up on screen.
Yeah,
Thank
so
you so
I'm
much.
gonna, the next question, if one confirmed case of a genuinely non-natural, whoops, my Slido always moves around just in the middle of reading it. There. If one confirmed case of a genuinely non-natural stellar disappearance were found, what would be the immediate scientific priority? Replication, classification, or theoretical modeling, and why?
What is confirmed? I mean, first we need to ask what is the definition of a confirmed vanishing. We see in the data that there is a deficit in the Earth shadow. So what is actually confirmed? Because we can always move. We can always move the goal. Now I don't know the word in English. I mean, it's a moving target.
This is a debatable word too, but an incontrovertible finding with corroboration from multiple observatories, multiple historic archives. Let's imagine it's essentially irrefutable. That at least, right.
I don't think they ever will be irrefutable as long as you have so big stigma as here. Even if something lands in front of on the White House, there will be people who will not believe it. There will be lots of scientists who say that this was staged. Even if so, I mean, we all the time have that trouble. People will always deny. Yeah. So I think that's the problem. When they created such a strong stigma that it's not the science, it's not the data, it's not the results that is the problem, it's the mindset of the observer.
Right, right. Well, the mindset is shifting, the Overton window is moving, so things are happening, and you're a part of that, and Beatrice on the science side. And I think your paper made quite the waves, and there's a lot of pushback because of that, because it threatens the fundamental paradigm upon which many scientists are seated in their careers. So good job. You're over you're over the target. You're taking flack. Never a bad sign. I think we have time for a few more questions, Chuck, if you'd like to walk us through.
Okay. This has been on a long time. Regarding land NHI artifacts, have you spoken with or looked at the research of Dr. Scott Walter? W-O-L-T-E.
No, but please feel free to send me an email with the links. I will be delighted to learn more.
All right, then I'm going to go back to one of Reed's. What is the current state of space-based Earth atmosphere?
We can skip that one because I did ask. We conversed on that one. I guess the last one is maybe still relevant. Oh, we could do that one.
Okay, I've got. So what would be some of your dream detection observation platforms or facilities to have full access to and directory of if you hypothetically had unlimited resources?
Well, it would be the ExoPro project, but with all the components that we need, not only like 1+1 telescope, but where you would have maybe 5 of them. You would have a number of PhD students working on it, a number of postdocs and technicians, and you would have a very fluent data collection. That would be a dream for me.
Yeah. And then somebody asked, hi, would like to ask where the slide images can be obtained in full. Does anybody access these?
Those, the presentation will be uploaded to the Human Institute site, and it'll also be in this YouTube video for instantaneous viewing.
Oh, I thought the question was about her slides that she examined.
I apologize. Okay. Well, yes, the slide deck we traditionally upload to the Human Institute site, if that's acceptable for the presenter. So, yes, will it be available? We will talk with Beatrice, and we will make available what's possible to do. Yeah. So we'll
Beatrice, I'm sorry, guys. I wanted to ask you, is your data available for others to search?
I mean, all the data we use is fully and publicly available. And it's like all the images are there, and also the paper of Enrique Solano describes how we get the transients, However, if someone is, I mean, for astronomers who want to use the sample, they can send an email to me and Enrique. And if it's a reasonable request, we will be happy to share. Of course, we do due diligence. If someone is working for RO, the chances go down. So,
Right. Yeah. Right.
Yeah, that was Aero, AARO. Yes.
no, but
Yes.
we have, I mean, both me and the others that are working in Vasco, we are European. I mean, we are European. We are government-funded European scientists. So, of course, we
Mhm.
can share data with other civilians that don't have any ties with any military or intelligence,
That's great.
and people who have reasonable requests simply.
You sort of addressed this next one, but I'm curious. What are a couple of the most prominent or persuasive critiques that you may have noticed from skeptics about this, and how sound? Whoops, again, it just disappeared. And how sound are their arguments?
So we have one skeptic who told me, "Oh, you have lots of plate defects at the edges of the plates," because yes, we do have false positives, and the thing is then what you can do is that you can look just in the center of each plate. You can look, let's say, within 2 degrees from the center, and you compare with a control sample, and you see it doesn't matter. You still have both the correlations with UFOs and with nukes, and you still have a deficit in the Earth shadow. So no, these plate defects on the edges doesn't matter. So the plate defect is the thing they always complain on. Then there is the empty systematic effect, or if a sample is contaminated, it's invalid, which would close down the whole LHC. So, I mean, this is the kind of arguments that I'm getting.
And Beatrice, I believe you said that there are potentially corroborating plates or data sets out there in other observatories that you could compare.
Yes. Yes.
To. And that might be a future line of effort.
Yes, and something we already started slowly working on. So,
okay. I have 2 quick questions to satisfy my own curiosity. You mentioned at one point in your slides an altitude of 42,164 feet. And I'm curious, from what you've gathered so far, are you able to discern not just specific altitudes relative, in the Earth's atmosphere, but even if something is in the solar system or is, halfway to Saturn, et cetera? Like how much can you distinguish distance?
So actually I can answer for something that I looked at this morning. We get very poor resolution after 100,000 kilometers altitude.
Okay.
So that's where we are getting so low numbers that we can't anymore say much about it if there is a deficit or not, because it's we get into low number statistics issue. But up to 100,000 kilometers altitude, that's pretty good.
Okay. And this is the next question is, you mentioned the detectable signatures, and I'm no astronomer, but I'm gathering that it's really the reflection of sunlight off of a solid surface that is the signature. And that's what degrades after 100,000 kilometers to the point where size, presence could be difficult to discern.
I'm not sure I understand the question.
I guess, well, my real question is, are there other detectable signatures beyond just the reflection of light that are interesting as an astronomer to be looking for?
If one looks for these active probes, it could be that they have their own light source. Like if you look for active probes in the shadow, then it's not reflection you look for, but then you look for some active emission, that they are having a lamp that is blinking or a lamp that is emitting.
Right. Or heat, or is there a chemical kind of constituency you could be detecting somewhat similar to how we detect organic molecules on exoplanets to surmise that there might be life there? Is there anything else you could be looking for as an astronomer beyond light emission, movement?
That's a good question. I haven't thought about that. I'm sure there are other ways how one can look for things. Okay. It's just that I've been very restricted in a very classical physics way, in the most simple and primitive way so far.
So to that, sort of in this an aligned question, could you define which type of surface could create a peculiar reflection? Must it be perfectly flat, or could it be curved? Could this?
I would say perfectly flat, because otherwise the second you start curving it, it's going to be streaking.
Interesting. And so you detected perfectly flat surfaces, essentially?
That's what I would say.
Okay. Also, a little follow-up there, there's been a lot of talk of this potential space-time bubble that surrounds a potential UAP, and that radar might have a difficulty, a signal bouncing off the object to the radar emitter. In terms of your work as an astronomer, would any theoretical or hypothetical insights into how a space-time bubble around a craft
Well, you can
might
look
affect
at the coordinates and see if you have very, 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 very precise measurements of the coordinates, you might see if they slightly shift.
Mhm.
That's one of
A
the
slight
ways.
shift.
Yeah, in the coordinates, and then you will be able to see if something is messing around there
Okay.
with the space-time.
I'm curious. There are some field studies going on at ground level looking at infrared signatures of unusual objects, things that aren't visible to the human eye. They're outside of the visual spectrum. And you mentioned looking for spectra coming off of these light sources. Do you think there's any value in an infrared survey of trying
Yes,
to follow
absolutely. It's
idea?
very interesting, but you need to think about the questions you ask and not just do the survey, because there's a lot of infrared surveys out there. You just need to have it very clearly what you want to look for, and make sure that it's unique and doesn't have 20 different solutions.
Mm-hmm. If I may also follow up on that, I'm interested in the Baltic Sea anomaly that you've worked on, and I have not read much up on it. I should, and I will. But what is the current state of our capability to, from space, I surmise, analyze the seafloor to look for abnormalities?
I'm afraid I can't answer that, but that's a question I've been wondering as well, because that
Okay.
would simplify our life a lot if we wouldn't have to go out there. But I imagine the resolution would be very poor, so you wouldn't be able to say if there's a right angle or something to
Under the
distinguish. Yeah, to distinguish a particular wreck, it must be very, very challenging.
Okay, so possibly, we can't just point our satellites downward and, understand if a USO is parked at the bottom of the Mariana Trench. It's not, in any
Depends
case,
on the
in any way
size of the USO, I guess.
Mhm.
Maybe it needs to be very, very big.
Yeah. Okay.
Well, so maybe along with that is the question: what are the most promising means available for civilian scientists and organizations to actively search for NHI artifacts in the atmosphere, ocean, underground? Any specific roadmaps that stand out as most important?
That's something we have to do, build those roadmaps, because I think currently it's missing. We need to really work on those roadmaps for each, for the atmosphere, for the ground, underground, and each of these roadmaps will need like people with specialities. To look underground, you will need the archaeologists helping you. And I think we need experts who can help us to build them. This is a big challenge, a community challenge we have ahead of us.
When I hear that, I always, because I come out of a finance background partially, I always think funding. That's what I heard that say. That you need expertise, you need instruments, and all that needs funding finally, which is an enormous challenge.
That's true. That's true.
Yes. Well, thank you so much, Beatrice, again for this original presentation, prepared for this series, and fascinating line of inquiry that we'll all be watching closely, and you have our full support in taking this down the road.
Thank you. Thank you a lot for inviting me.
Yes, thank you so much. And with that, yes, a hearty applause for the brave scientists.
Just awesome.
Yes, it's amazing. This is advancing the discourse. This is moving the needle, in my perspective. And that there's many needles that have to be moved. And one is in the scientific and academic world. It's a difficult needle to move. So anyone who's willing to take those professional risks, say what they see, present the data, even if it does not fit or comport to the current model. And also, to Beatrice's point, to be specific, to go within a catch-all acronym like UAP or NHI, and to be more exact in terms of what are we looking for, to make a hypothesis,
right,
and to go find the data to substantiate or to falsify it. So I commend that courage. Chuck, thank you so much for guiding us through the Q&A and for all your coordination.
My pleasure. This is part of history, pal. This is part of history.
I know you're having the best time of your life. I don't even have to say thank you. You could say thank you to us. No, we are, all three of us, Ted, Chuck, and I, we meet often, and we're excited to receive new abstracts from new presenters. We're about to announce the next section or segment of the series on looking for signs of intelligence, intelligent activity, behavior, looking at craft, taxonomy, and alleged morphologies to begin to understand what is the intelligence that could be behind what is being observed in the UAP phenomenon. So we have an exciting roadmap ahead, and we're enjoying every minute of it. And we can actually bring Ted back on stage here. And Ted and I are just going to kind of make some closing statements from the perspective of UAP Med and Human Institute. And then we'll talk a little bit about where the series is going to go next.
First off, the series is great. I'm enjoying this, and I hope that our listeners and viewers understand that all of these lectures are dependent. They're codependent. Each of the lectures supports other ideas, and the whole idea is to develop a better view on how to approach the idea of a science of non-human intelligence. It's a real privilege to work on it, and we have more brilliant minds coming. I'll take just a moment to talk about UAP Med just for a second before I kick it back to you, Reed. UAP Med is committed to providing education and improving medical care for UAP experiencers by advancing scientific inquiry, public understanding, and healthcare professional competencies through responsible, evidence-driven clinical dialogue. Responsible engagement about UAP exposure among citizens, healthcare professionals, and government agencies can achieve the following goals. It can empower patients to overcome barriers to critical health services by eliminating UAP stigma. It can support healthcare professionals who are encountering an emerging and unique patient population, and it can improve safety in collaboration with government agencies, emergency services, and local communities. UAP Med has assembled a dynamic team of healthcare practitioners, specialty researchers, law enforcement experts, and emergency service professionals. Through this unique collaboration, UAP Med seeks to bridge the gap between science and societal needs, catalyzing research and public policies that translate into effective assessment, treatment, and safety for anyone that experiences a UAP exposure. I'll hand that back to you now, Reed.
All right, great. Thank you, Ted, the UAP Med team, for leading the charge on that very vital aspect of the phenomenon and its potential interaction with both ground observers and individuals who are approached more intimately by the phenomenon, which is not a comfortable topic, but one that has to be tackled in the public interest. So it's a pleasure to be collaborating between our two organizations. A word about the Human Institute. Our mission here at the Human Institute is to bring the study of UAP and potential NHI out of the shadows of secrecy and speculation and really into the light of rigorous public discourse. We're seeking to accelerate humanity's response to the realities and implications presented to us by emergent phenomenon and bring scientific rigor and strategic foresight to empower citizens like yourselves, to equip decision makers with essential data and knowledge, and to help begin this process of coordinating international responses to what may be an emergent set of non-human phenomena. To achieve this, we're working to generate new and novel data sets, to undertake empirical research analysis upon that data, and to develop cutting-edge products and platforms for the public that address key gaps in society's ability to contend with this new reality, and at the same time to translate essential findings into actionable insights for policymakers and for the private sector. We currently have 3 public initiatives, which we can put up on screen here, and I encourage you to take a look and get involved. And one that I'd like to speak very specifically about is UAP Summit, uapsummit.org. The UAP Summit is a 2-day virtual conference, February 7th and 8th, in which we will converge all of these different groups, academic teams, research and field units that are out there attempting to detect and to track UAP, and to really converge them into one space, talk about what are our emerging capabilities to viably detect anomalies in the atmosphere, to understand what is flying over our cities, our homes, our coastlines, to gain in aerial intelligence on behalf of the public interest, not reliant on any national security state to provide us in good faith that information, so that we understand our skies ourselves. The capabilities are already here, the experts are arriving. And so we're at this kind of exciting moment where society on its own behalf can generate key insight, again, into what is up there and potentially down there in the oceans as well. We're going to have sessions on the current state of UAP. We have a congressional representative heading up that session. We're going to have a session on USOs, and we have an exciting format with over 23 speakers. So I highly encourage you to grab a seat at the summit. We're making it affordable and accessible to the public, and we definitely want you to be a part of this conversation. This is really being done in the spirit of not just the public interest, but at the Human Institute, we frame it even broader. We talk about the human interest. So much of the UAP topic is aggregated under national security conversations. It's within these exclusive domains of interest relating to one nation, one defense company. We need to broaden that and begin to consider this in the human interest as a potential species-wide engagement, and really articulate, what are the key principles, the capabilities, the potential violations and remediations that we need to enact in light of the longstanding secrecy, whether it be human or non-human, surrounding this phenomenon, and really begin to articulate our human intent and generate the protocols that would be necessary to enter into a future hypothetical set of diplomatic scenarios. So the Human Institute is working on that, and the beginning insight into what is in our skies via detection and tracking through existing technologies at our disposal is a vital part. It's kind of like a key capability that any civilization needs before they can interface with whatever's out there. They have to be able to see what's in their skies and to track it effectively. So the summit was conceived to tackle that exact issue. And so in my view, and I know this from those I work with across the board throughout the community, we're crossing a threshold right now from speculating regarding what might be out there to confronting evidence suggesting that engagement may already be occurring, whether consciously or unconsciously. And this series that you're watching, Investigating NHI, is really about bringing together scientists, philosophers, researchers, investigators, clinicians, and experiencers to share the emerging findings, the new data, and original perspectives regarding what that engagement might be and how we might begin to navigate it, not just as a nation, but as a world. So very exciting to share this with you all. The outcome of all these efforts may be nothing less than a new field of inquiry, NHI studies. This is what is in the birthing. So your being here, a part of it, is so important. I want to thank those who are supporting UAP Med in its public interest mission, as well as Human Institute in its mission. If you'd like more information on how to do that, you can go to humaninstitute.org. So with that, thank you again for joining us for this third lecture in the Investigating NHI series. The roadmap has us going into signs of intelligence. So we'll be looking at the historical record of the UAP UFO phenomenon to look at what signs of intelligent behavior, intentional signaling, possible communication and interaction, possible interference or manipulation of technology and observation, human observation, might be present in that record. What might we begin to understand about the intelligence that is behind the structured craft observed in the UAP phenomenon? And we'll be touching many other aspects in this 3-lecture series to come as well. Also keep an eye out for some exciting multi-speaker panels that we're beginning to design and schedule. We hope to bring back onto the stage former speakers in the form of a live panel discussion, basically synergizing their insights and findings and further cementing, what is it that we've established in this series and how can we build upon that block by block, brick by brick. So Keep an eye out. If you haven't registered, please go to humaninstitute.org/NHI, and you can register for the series. You'll get post-lecture recaps. You'll get early access to Q&A with the speakers and notifications to keep you in the loop as we go forward. So with that, thank you so much for joining us, and we will see you at the next lecture at Investigating NHI.